The girl who asked, why? About the universe. Avis was fascinated by the night sky. While others saw stars, she saw questions. Why do stars shine? How do planets move? What's at the edge of the universe? Her parents smiled. You might be a scientist one day, her father said. Not just any scientist, Avis replied. I want to study the universe itself. From that moment, she dreamed of becoming an astrophysicist, a scientist who uses physics and math to explore how the universe works. What astrophysicists do. As Avis grew, she learned that astrophysicists are explorers of space, but instead of rockets, they use telescopes, computers, and equations to understand the cosmos. They study everything from black holes and galaxies to planets and light waves, asking questions like, how do stars form and die? What is dark matter made of? How old is the universe? Astrophysicists use physics and mathematics to describe how things in space behave. They telescope observe, collect data from telescopes on Earth and in space. Analyze, use math and coding to study cosmic patterns and predict behavior. Theorize, build models that explain how galaxies form or why stars explode. Collaborate, work with scientists around the world to share discoveries. Teach, guide students and inspire future scientists. Avis realized that being an astrophysicist meant thinking like a detective of the universe, solving mysteries written in starlight. High school preparation. In high school, Avis focused on subjects that helped her understand the science behind space. Mathematics, algebra, calculus, and statistics helped her calculate distances and forces. Physics. She learned how motion, gravity, and energy shape the universe. Computer science. Coding allowed her to process data and run models. Earth and AMP. Space science, to study how planets and stars interact. English and AMP. Communication, to write clear research reports and explain complex ideas. She also joined the science club, built model rockets, and entered her school's STEM fair, where she explained how gravity affects planetary orbits. Post-secondary training. After high school, Avis earned a bachelor's degree in physics. She studied mechanics and motion, quantum physics, thermodynamics, optics and light, data science and programming. She then pursued a PhD in astrophysics, where she conducted her own research on how galaxies evolve. During graduate school, she learned to use telescopes and supercomputers to model the behavior of stars and galaxies. Her research led to exciting new insights about how black holes grow over time. Other requirements. Avis discovered that being an astrophysicist required more than intelligence, it needed patience, creativity, and teamwork. She developed analytical thinking, to interpret data from telescopes and simulations. Coding skills, writing high-level programs to analyze large datasets. Mathematical ability, to build models and test predictions. Problem solving, tackling tough cosmic questions. Communication, sharing discoveries through papers and presentations. Curiosity, always asking new questions about the universe. She also learned the importance of collaboration, as most discoveries are made by teams of scientists working together.